Good evening, students. Today we are explain about SP3 hybridization. Simple definition of SP3 hybridization: the phenomenon of intermixing of one s orbital and three p orbital will produce a new set of equivalent hybrid orbital that was said to be SP3 hybridization. In SP3 hybridization, S character, S percentage is 25 percentage and P percentage is 75 percentage. For suppose this was explained on the basis of one example. The best example was CH4, methane. The best example is CH4. So with the help of CH4, so we can explain the SP3 hybridization. So in SP3 hybridization, so for suppose carbon CH4 methane. So in central atom is the carbon. Central atom is the carbon. The configuration of the central atom is 1s2, 2s2, 2p2. So here we should write 1s2, 2s2, 2p2 in orbital representation. Then after, so we should write excited state configuration. Here one electron is excited from 2s orbital to 2p orbital, 2s orbital to 2p orbital. So that we should write excited state configuration as 2s1 and 2p3, 2s1 and 2p3. So right now one s orbital and 3p orbitals are fused to give sp3 hybrid orbital, 4 number of sp3 hybrid orbital. For suppose when we are seeing the orbital representation, so means one s orbital, that was 2s1 orbital and 2px1 and 2py axis, 2py1 and 2pz1 on the axis. So they are intermixed and giving 4 sp3 hybrid orbital, 4 sp3 hybrid orbital. This is said to be sp3 hybrid. So right now here, so this sp3 hybrid, so what is happens, sp3 hybrid in CH4, how many molecules, how many hydrogens are there? There are 4 hydrogens are there. So means this sp3 hybrid is overlapped with 4 s orbitals of hydrogen, 4 s orbital. So one side from 1 2 3 4 sides. So means that is overlapping, sp3s overlapping can takes place there. So means sp3s sigma bonding is formed, 1 2 3 4 sp3s sigma bonds are formed. Right now here, for suppose when we are writing the structure, so carbon as central atom, hydrogen, hydrogen, hydrogen and hydrogen, the bond angle is 109.5 degrees. So whenever any one undergoes sp3 hybridization, that has tetrahedral shape, tetrahedral shape. So this is the carbon, hydrogen, 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 hydrogen. It is a 3D view. Means here carbon, hydrogen, so means 1 and 2 carbon, hydrogen and hydrogen are present on the plane of the paper. And next thick line, the hydrogen which is present on thick line, so was towards the observer, and this hydrogen away from the observer. For suppose when we are seeing this one, by taking one example, by taking one example, by using 4 pens, by using 4 pens, for suppose this is the, just you can see here, so these are the 4 pens here. So just you can assume this is the carbon, and this was the hydrogen, and this was the other hydrogen, and this was the hydrogen, and this was the hydrogen. Just you can think here, so this hydrogen and this carbon and hydrogen are present on the plane of the paper. So this one is towards the observer side, and the green one is the away from the observer, away from the observer. And the bond angle in between these all are the 109.5 degrees, 109 degree, 109.5 degrees. Here also 109.5 degrees. Here also 109.5 degrees. Understand ma? So this is the tetrahedral pattern, tetrahedral pattern anyway. So tetrahedral pattern, tetrahedral structure. It is the structure of CH4 molecule, carbon, hydrogen, hydrogen, hydrogen and hydrogen. Thank you.